This will blow your mind. A sacred geometry coil that is a dielectric inductor, and it can perform a task that no component that we currently have can. There's no inductor that can do it, and there's no capacitor that can do it. But this is like a hybrid of an inductor and a capacitor. You just wait. So right now I've got a little, Baofeng thingy with a very typical commercial antenna. Unfortunately I have a terrible phone camera, but anyway, it's basically a quarter wave monopole at 2 meters. Right? So nothing fancy there. And of course I become the other side of the antenna. 147 megahertz receive. Transmit frequency is set for a repeater in Geelong, which is a long way from here. Let's key up. I don't hear a repeater tail. Let's move it. No, nothing. Nothing. Now, what I'm going to do, I'm going to flip over to another quarter wave monopole with my amazing invention. So just stand by. Okay, so exact same frequency. I should just show the power setting. It is on low. But now, sacred geometry going on here. Transmit, and let's see what happens. Oh, sorry, hang on. I got to exit. Oh, no, exited. That's good. All right. Here we go. This is VK3 VKE, just testing repeater access. Beautiful. So, the Geelong repeater is a long way from here. Now, I could access the Geelong repeater with this, but I would have to very carefully position myself where I get reflections off the shutters and phase it in order to actually get the Geelong repeater with this quarter wave monopole. Now, of course, well, it needs another side of a system, but it had it, didn't it? I was holding the radio. This thing gives me the other side of the system and more. So let's try this again. And I'll have to get in closer to do the right thing. I'll get in closer to the radio. This is VK3 VKE, just testing access to the repeater. There you go. Now, this is mad. So what I'm about to share with you is a world first, or at least, well, it is actually a world first. I was going to say at least maybe Tesla did it, which I'm sure he did at much lower frequencies. But it's definitely a world first for VHF, okay? So, this tiny little thing actually does an amazing thing. This won't make sense to the average person that's, been educated in electromagnetics or even just general circuit theory. The only reason it makes sense to me is because I kind of rewound the whole electromagnetic evolution and went back down to basics, and I'm starting to see where we've gone wrong in certain areas. So, and then engineering back up from there, I've been able to come up with some pretty exciting things. So, for example, right, all right, imagine, hang on, I'll get my hand in the picture. All right, so there's you holding the transceiver. So that's symbolized as you and your chassis ground, okay? AC signal source is, of course, differential between chassis ground and the active element, which is what's going on with your little handy talkie, where it's making this element positive and negative at frequency with respect to the chassis, and then of course you holding it, or even if you added a counterpoise wire. When you let go of one of these things, they're extremely inefficient because this thing has nothing to work against. So my new system not only it doesn't actually give it something to work against per se, in the aperture sense of the antenna, but it does give it something to work against internally, and it feeds back and builds up the energy. And of course, then whatever the electric field changes on the active element are, their higher energy, then as they duct towards their opposites, they create stronger rotating magnetic fields. The basic principle is connecting at chassis ground, not at the antenna element. So if you imagine, if your little walkie-talkie has a point that is at chassis ground and then a point that is the active element. I just want to make this clear because I know people do get confused with these things, and not all as obsessed as me. So looking at this, for example, this one, it has the active element, but if you get right down to the bottom here, I'll try to get this to show. Obviously, it's a two-terminal, very hard to see, two-terminal conductor. But as you can see anyway, it's just like any other coax. Has a center conductor and a shield. So what I'm about to show you connects only to the shield. So you could put a nice little neat eyelet over there, and then screw it on, right? The eyelet connection would then connect to the center conductor of this coaxial spiral. So we use a very short length of coax, just enough to be able to go 1 turn, 2 turn, 3 turn, radially outwards. So 1, 2, 3 turns of coax. Ideally, having a low impedance coax like a 50 ohm is better, and more importantly, a coax with a foam dielectric, because if it's one of those harder sort of insulators between the center conductor and the shield, you're getting dielectric losses. And the purpose of this design is a dynamic capacitance, which is all about dielectric. So this is a dielectric inductor. So the center conductor of this coaxial winding, and at the center of the winding, connects to, and for example, here's another antenna, a similar thing, active element, chassis ground. So if you did it on here, center conductor of the coax connects here. You make sure you isolate and terminate the shield. It connects to nothing in the center. You wind your coax outward in a spiral 3 turns. It's very tough to do. You might want to heat it up as well and soften it up to do it and glue it in place. Once you've done your 3 turns, so we're connected again at chassis ground to the center conductor in the middle. We wind out 3 turns, and then we actually terminate the center conductor on the outside. Make sure it can't connect to anything. We're connecting on the inside at the center, but make sure we don't connect to anything on the outside at the center. What we do is we run a short wire from the outer part of this on the shield back to the very center conductor that connected to the chassis ground in the first place. Now, from a classic perspective, you would say a component that connects here on its input and then has its output connecting here would just not be seen. You say it's a joke. But trust me, it's seen. Because, and now please don't hit me with all the links of the science and the bloody electromagnetic theory, because I've moved beyond that, and that's why I'm sharing this, all right? Yes, wow, it's all wonderful, but guess what? There's a lot of flaws, and so I'm not really interested, so don't waste your time. When we drive this active element, and we are all educated to say we're driving currents, the only thing that causes currents are changing electric field potentials. Currents are moving electric charges, and the only reason electric charges move is when they're moving to something that's different to them, or they're being subjected to something the same that they're repelled from. And when electric charges move, they create rotating magnetic fields. So let's say in one half of the cycle, we start to increase the electric positive charge potential here. We start to drive positive charges in this way. They create rotating magnetic fields. But guess what else happens? As positive charges move this way, just like when you blow smoke forward and you notice some coming back, we have a back run of negative charges running the other way. I'll point that out. Imagine, positive charge running this way. Right hand thumb rule. And by the way, I'm talking about charges, not current. Positive charge running this way, right hand thumb rule, rotating magnetic field. The rotating magnetic field would be up and out of the page in this way. So a positive charge moving that way would be what we consider to be conventional current. When this happens though, this positive charge automatically creates negative charges around it running in the other direction. Negative charges, when, let me see, I'll show you here. If the positive charge is running this way, and right hand thumb rule out of the page, all right, and it creates this rotation. If a negative charge was running this way, it would create the other rotation. So back to where I was before, back on here. So as positive charges are driven up, it creates surrounding negative charges traveling down. The positive charge has a particular rotation, but the negative charges going the other way actually match that rotation, because positive and negative charges going the same way have an opposite rotation. So positive charges going opposite ways have the same rotation. So when we drive a positive charge up one element, it induces a negative charge running down the exterior of the element, and this is what I harness with this system. So when this is becoming positive, the negative charge flows down, and here where I'm connecting to the chassis ground, I take that negative charge and I hide it away in this center conductor. As transitional aspects go, well, it can create a current. But the other thing is, when this negative charge does this in the middle of this coaxial run, it by default makes the coaxial shield positively charged. So just like a typical, this pen's not working very well, capacitor, if the negative charge is running along the middle, it's making the shield positive. But this is like a directional capacitor, this is a non-directional capacitor, because negatives come in here and go both ways, so their magnetic fields cancel. Positives here, both ways, cancel. This is a non-cancelling of the magnetic fields. It stores both the electric and magnetic fields. So as the negative charge rushes in, it doesn't matter about the resonant length, because it is also a capacitor. it has stored the magnetic rotation and created the suitable magnetic rotation on its opponent. And this is where we're really lacking something, which makes the other one, the outer shield, positive. But the outer shield is connected back to where it came from, and it was negative. Guess what? It can continue. Positive attractive to negative. So this actually acts as an accelerator. 7-3, and thanks for watching.